Okay, I think we are recording. All right, we're not going to get very far because we have shortened class periods and we've wasted all but like 5 minutes. So here we go. 5-7. Rectilinear motion revisited using integration. All right, we're going to get through example 1. Here's the deal. I stumble across that word and it's just a struggle. I said rectilinear. It's fine. Whatever. Okay, you have the position function, which usually we represent it as S of t, right? Yes, S of t, like the position that something is at. So like falling off a cliff, you have like a rock that is...
S, not P.
What? I don't know. I don't know why they call it S. So like S of t equals... Let's go. I don't know. Negative 16 t squared plus 100. I don't know. Something like that, right? Negative 16 t squared plus 100. Let's say that that's the position function, right? Okay. If I take the derivative of that, okay, then I get velocity. Okay. And the velocity would be v of t. And if I do that, v of t is equal to, in this case, like negative 32t or something like that, right? Okay, the 100 is going to drop off. Okay? And then if I take the derivative again,
Velocity is v of t.
v of t, and v of t would be negative 32t. And acceleration would be a of t. And a of t in this case would be negative 32. So that means you are accelerating at a constant rate of negative 32 meters per second squared. Okay? Like you're constantly accelerating. So each second you're going 32 meters per second faster than you were the previous second, right? You're accelerating at a constant rate until you hit terminal velocity and blah, 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 all that stuff, okay? Now we're going to be looking at going back the other direction. So if they give me an acceleration,
We gotta go backwards.
we gotta go backwards. How do you go backwards?
Antiderivative.
This is the antiderivative. Okay, now, hold on. What's the antiderivative of negative 32? Of negative 32?
Negative 32x.
Is negative 32x, or negative 32t plus c. How do you find out what c is?
Plug it in.
They will say the velocity at a time of whatever is whatever, and then you can plug that in and you can find for c, right? Okay, then I do the antiderivative again, and I get s of t, and the antiderivative of negative 32t plus c is going to be negative 16t squared plus
C squared.
ct
Oh.
plus your second constant.
Oh, dang it.
I'm going to call it c1 because this constant will be different than the other constant, right? So whatever your constant was here times t plus whatever your second constant is. Now you can find out all of these constants as you go along by plugging numbers in. That's what we're going to do in example 1. But this is saying that you can do the antiderivative and do the process backwards, okay? So in other words, down here they say the velocity is the derivative of the position function,
Correct.
okay? And the acceleration is the derivative of the velocity, okay? But going back the other direction, the position function is the antiderivative of velocity. And the velocity is the antiderivative of the acceleration function, right? So you're going back the other direction. Whatever. I like my visual better. But anyway, example 1. Let's get through this one and then we'll be done. Blah, blah, blah. Suppose that a particle moves with a velocity of this thing. Cosine of pi t along a coordinate line, assuming that the particle has coordinates of blah, 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 find its position function. So we are going from velocity back to position function. So we're going velocity to s, okay? So to do that, I am going just antiderivative of cosine of pi t. Now, don't think that 0 and 4 are your limits of integration. They are not. That is just going to help us find c when we go backwards, okay? So you are doing...
Like coordinates.
You are doing strictly an indefinite integral. You will not have numbers here and here for this thing, okay? So we have to find the antiderivative of this thing.
Sine pi t.
Now, problem is,
Is it negative sign?
I think maybe we'll have to use
U.
u, right? U is pi t, And what's the derivative of pi t?
1/2 t squared.
No,
Pi.
no,
Pi
derivative,
reduced.
derivative.
Oh, sorry.
Derivative. What's the derivative of pi t?
I don't know.
It'd be like the derivative of 3.14 t.
Oh, pi.
Just pi dt, right? Okay. Oh, and this should have a dt on the end of it here. Okay. So, to get rid of the pi here, because I have to get rid of pi, I'm going to divide by pi. So I'm going to say 1 over pi is there, right? Okay, maybe. All right, so now I start to substitute. So I'm going to put 1 over, well, I'm going to do this. Here's my integral function. This is now cosine of u, right? Cosine of u. And dt, which is here, is getting replaced with 1 over pi du. So 1 over pi du. Do we kind of remember this process-ish?
Yeah.
This is kind of a weird thing. Okay. Now we do the antiderivative of cosine. What's the antiderivative of cosine? The derivative of sine is cosine, so the antiderivative of cosine is sine. Yes. 1 over pi sine of u, but u is pi t plus c. Okay.
Now we plug in.
And this is like y equals that, right? Or what do they call it? This is the position function, so s of t equals this, right? Okay? And it says s is 4 at a time of 0. S is 4 at a time of 0. So I'm going to plug 4 in here, and I'm going to plug 0 in there, and that's going to help me solve for c. Okay? So, pi times 0 is 0. What is sine of 0? Sine of 0 is the y-coordinate at 0, which is 0, right? So this is 0, and 1/4 times, yeah, so c is going to be 4. So my final position function is s of t is equal to 1 over pi sine of pi t, t plus 4. Okay, not so bad. They started you off with a really, really hard one using sine and cosine. But then you're just plugging in the values they give you to solve for your constant. That's all. You're just going backwards instead of going forwards. Okay? That is all.